So tutorial 13th, we will be discussing few problems based on capacitors, voltage, current, power and energy relationship. In tutorial 12, we have covered the inductors. Now we are covering the capacitors, and then we'll go for first order and second order circuits. So problem 1 is a very basic problem. You have to calculate the charge that is stored in a 3 picofarad capacitor with a 20 volt across it. Also determine the energy which is stored in the capacitor. Okay, so that is what you have to determine, the charge and the energy. The capacitor value is 3 picofarad and the voltage that is given is 20 volt. So this is a very fundamental problem in capacitor. The solution goes like this. So the basic relationship between the charge, capacitance and the voltage is basically Q is equal to C into V, where the capacitance value is given to be 3 picofarad and the voltage is given to be 20 volt. It means the charge stored in the capacitor will be equal to 60 picocoulomb. Then we need to determine the energy. So energy stored in the capacitor is basically Q is equal to half CV square. Now we have been given the voltage, we were given the capacitance value. So what is the energy which is stored in the capacitor? Energy stored in the capacitor is half, capacitance is 3 picofarad and the square of the voltage, that is 400. So energy is equal to 600 picojoule. So energy unit will be in joule and charge unit will be in coulomb, and the capacitance unit is always in the farad. But farad is a very bigger unit, so usually we have microfarad or millifarad as the capacitance value. Problem 2, the voltage across a 5 microfarad capacitor is given to us. Calculate the current through it. So we have to determine the current, which is a function of time, when a capacitor is 5 microfarad and the voltage is 10 cos 6000 t volt. So we know that the current through a capacitor is equal to C dV by dt. So we have the differential of the voltage. Voltage is a function of time. So if we differentiate the voltage and then substitute the value of the capacitance, we will be getting minus 0.3 sine 6000 t as the current. So here we are getting the current also as a function of time and voltage also as a function of time. So if we need to determine the magnitude of the current at a particular time, then we have to substitute that time in the current equation. So first two problems are very simple. Problem 3, determine the voltage across a 2 microfarad capacitor if the current through it is given to us. Assume that the initial capacitor voltage is 0. So the initial voltage that is stored in the capacitor is 0 and the current is given. Now you have to determine the voltage. So in the previous problem we determined the current, now we will determine the voltage. So voltage is equal to 1 by C integral of the current with the initial to final value. Now the initial voltage is equal to 0. This means we will not have any initial quantity. Now the current is a function of time which we have to integrate from 0 to t, substituting the value of the capacitor. Then we get the voltage as 1 minus e to the power minus 3000 t volt. So we have got the voltage as a function of time, where the current is also a function of time. Problem 4, determine the current through a 200 microfarad capacitor whose voltage is shown below. Now the previous 3 problems we have gone with the direct formulae to solve the numerical. Now here in this we will be using the graph. So the waveform of the voltage is given to us. So voltage variation with respect to time is given. So these type of problems we have already solved in the inductors in the previous tutorial. So similarly we will solve in case of a capacitor. Capacitance value is 200 microfarad and we have to determine the current for the voltage given to us. So you know that when the voltage waveform is given, then we have to split this voltage waveform into different time zones so that we can form some mathematical equations. So the time is split between 0 to 1, 1 to 3 and 3 to 4. After 4 you have otherwise, which is below 0 or after 4 you do not have any magnitude of the voltage. However, with respect to time, if we see from 0 to 1 second, because time unit will be in second, then this is a straight line whose equation you can write as 50 into t. Similarly, from 1 to 2 second, you can write the equation to be 100 minus 50 t. From 2 to you have 3 to 4 seconds. Now you can cover this entire zone into one straight line. So either you can split from 1 to 2 or 2 to 3, or you can combine this from 1 to 3. Now from 3 to 4, you have another line which is a break here. That equation you have to write. So combining that, we will get the voltage equation. Now we know that current is basically C dV by dt. Capacitance value is already given to us, that is 200 microfarad. So we have to differentiate this voltage equation in this dV by dt term to get the value of the current. So we will be having this current as a function of time t, and when we substitute the value of the time, we will be getting the magnitude of the current for the different instant. So different instant, what is the magnitude of the current we will be getting on differentiating the voltage, which is a function of time. Now after that, once we have obtained this magnitude of the current, we can obtain the corresponding current graph with respect to time for the given voltage with respect to time graph. So here the maximum magnitude is 10, because we have the 10 here as the maximum magnitude, and from 1 to 3 second you can see it, the magnitude is 10 milliampere. So here we have 10 milliampere as the magnitude from 0 to 1 second. Then from 1 to 3 second you have a magnitude of minus 10, and from 3 to 4 you have a magnitude of 10. So in this way you can draw the graph or the waveform for the given voltage. You can obtain the current by differentiating the voltage with respect to time t. Problem 5th. Now we are in the circuit problem. Obtain the energy which is stored in each capacitor under the DC condition. So we see we have a capacitor of 4 millifarad, and here we have a capacitor of 2 millifarad. So what is the energy which is stored, V1 and V2? First we have to find the voltage, and then we can find the energy, because energy will be equal to half CV square. So I need to find first the voltage first, and then I can determine what is the energy which is stored in the two capacitor. So under DC condition, what will happen? Under DC condition, you have to replace the capacitors with a open circuit. You know that DC condition, the current will not flow through a capacitor, and hence it will be a open circuit condition. So once the capacitor has become open, so this is open circuit and this is open circuit, then the current that is flowing through the series combination of 2 kilo ohm and 4 kilo ohm capacitor, because this part of the circuit will become open, this part of the circuit will become open, then there will be a current which is flowing through the series combination of 2 kilo ohms and 4 kilo ohms. So this we will be getting from the current division rule. So we know that the current which is flowing through nth resistor, so it is equal to the source current, which is equal to 6 milliampere, multiplied with the parallel combination of that. So what is the parallel combination of that? That is 3 kilo ohm here. So that will come in the numerator, and on the denominator you will be having all the combinations. So I'm getting 2 milliampere as the current which is flowing as a series combination of 2 kilo ohms and 4 kilo ohm. Now after that we can determine what is the voltage V1 across the 2 millifarad capacitor and V2 across the 4 kilo ohm capacitor. So since the current I was flowing his side, I being 2 milliampere, we will be having equal voltage V1 here and V1 here, because both two are in parallel. So V1 is equal to 2000 into current I, because we have a 2 kilo ohm resistor which is equal to 4 volt, because here the current is in milliampere. The voltage 2 is basically 4000 into the current. Now same current is flowing here in the DC condition, so we will be having 8 volt across the capacitor 2. So once we have got the voltage of the first capacitor and the second capacitor, we can determine what is the energy which is stored in the capacitor with the formula half CV square. So here we have a different capacitance value and different voltage value. So we are getting 16 millijoule and 128 millijoule as the energy which is stored in the two capacitors. Problem 6th, you have to determine the equivalent capacitance between the terminals. So here we have the terminal A and here we have the terminal B. You have to determine what is C equivalent in this particular circuit. So you can see that 5 microfarad and 20 microfarad will be in series, and then it will be in parallel with 6 microfarad, which will be in parallel with 20 microfarad, the combination, and then it will come in series with 60 microfarad. So series parallel combination, you have to do it. Now, what is the equivalent capacitance for 20 microfarad and 5 microfarad? That two are in series. So the series combination of that, you know that resistors and capacitors will behave alternatively. So if you have the capacitor C1 value, capacitor C2, C1, C2 divided by C1 plus C2 will be the C equivalent under series condition. So when series condition is there, so we have a 4 microfarad capacitor as the series equivalent of these two capacitors. Now we also know that these equivalent capacitance will be in parallel with 6 microfarad capacitor. So we have a 4 microfarad capacitor and 6 microfarad capacitors which are in parallel, and that is also parallel with 20 microfarad capacitor. So we can add all this as C equivalent plus we can write C2 plus C3. So 30 microfarad capacitor value we are getting till this end. Now finally we can say that 30 microfarad capacitor is in series with the 60 microfarad capacitor. So the net equivalent capacitance of this entire network seen from the terminal end is equal to the final value we are getting 30 microfarad, which we need to calculate the series combination with 60 microfarad. So 30 into 60 divided by 30 plus 60. So 20 microfarad is the net equivalent capacitance for the entire circuit. Problem 7. Find the voltage across each capacitors. So we have different capacitors 50 microfarad, 70, 20, 60 and 120. We have to determine the voltage across each capacitors. Now the first thing that you need to do is determine the value of C equivalent when you see in the terminal, because we have to determine the voltage. So here we see that 40 and 20 capacitors are in basically in parallel combinations. Okay, so you can add both to form a 60 millifarad capacitors, and then the 60 millifarad I think it will be microfarad will be in series with 20 and 30. So similar to the previous problem, we can easily solve this. So this will be 20, I think. So here we will do that operation and try to find the equivalent capacitance of this entire network. So it will be in microfarad because all the capacitors are in microfarad. Let me see. Okay, here you have microfarad and here you have microfarad. If you take it, then it will be 10 microfarad. So combined to the solution number 6, whatever we have, same process we are going to do it, because these two capacitor will be in series, which will be in parallel with 20 microfarad, and then these two capacitors are in parallel, which will be coming in series combination. So 10 microfarad is basically the C equivalent. Once we get the equivalent value, I can determine what is the total charge of the circuit. Total charge is basically C into V. So 10 millifarad or microfarad, anything we can take it, because it doesn't depend upon the unit. We can change this unit anytime. So this is only a problem. So the charge is basically 0.3 coulomb. That is there for the entire system when seeing at the terminal. Now once we get the value of the charge, now the problem is to determine the potential across each capacitor. Now these two capacitors are in parallel, so obviously their voltage will be equal. These two capacitors, there will be a voltage division, okay, and then the net voltage division will be in parallel with 20 microfarad capacitor, so that will be equal. So we have to determine the potential of V1 and V2 across the capacitors individual, like 20 millifarad and 31. So first we determine that one. So we know that voltage is equal to charge divided by the total capacitance. Then we can determine what is potential V1. Similarly, charge divided by the potential C2, we can determine the voltage V1 and V2. Once we have determined the voltage V1 and V2 across the series combination of the capacitors, then we can finally determine what is the voltage V3 using the concept of Kirchhoff's voltage law. The same answer of 5 volt across V3 we can get again if we divide the charge with respect to the capacitance. So there are two different methods of obtaining the voltage. One by voltage is equal to charge divided by capacitance, or otherwise we can apply the KVL concept. There will be a charge conservation in the series circuit. So we have a KVL concept also giving us 5 volt, and V3 by charge conservation also it is giving 5 volt only. Problem 8. Assume that capacitors are initially uncharged. So here you have 6 microfarad and 3 microfarad capacitors. Both are initially uncharged. Find V0. V0 is the potential which is across the 3 microfarad capacitor. Now the source current Is is basically given in milliampere with respect to time t. So we can divide this into two time zones from 0 to 1 and 1 to 2 second with a maximum amplitude of 90 milliampere. Now how to determine that voltage V0? Let us see how to determine. So the voltage V0 is basically 1 by C integral of the current. What is the current which is flowing here? So from 0 to 1, if we split it, we know that current is equal to 90 into T. This is the equation. This equation we will getting 90 into T. Now that current we will substitute here and integrate to get the voltage. So at 1 second, we will be getting the voltage as 15 kilovolt. Now what happened from 1 to 2 seconds? So this part of the graph, the current equation is 180 minus 90t. Then we substitute this current in the voltage equation and then we integrate. Now understand here is that from 0 to 1 second there will be some voltage which will be present initially in the capacitor, because the capacitor has been charged to a voltage of 15 kilovolt from 0 to 1 second. So that will become the initial voltage in the second case from 1 to 2 second. Now once we integrate that, we will be getting the entire voltage equation for 0 to 1 and 1 to 2 second. The equation is 15t square kilovolt and the other equation is 16t minus 15t square minus 30 kilovolt. So we can get the potential V0 of t that is discontinuous over the time 0 to 1 and 1 to 2 second. This is the last problem for today's tutorial. We have to determine the current I1 and I2 and the potential V of t, given that the initial voltage in the capacitor is 0. So the source current Is, that is in milliampere with respect to time, is discontinuous. So we can see from 0 to 1, 1 to 3 we can plot, and from 3 to 5. Now I1 and I2 are the current which are flowing through 6 microfarad and 4 microfarad capacitor, where the voltage V will be same for both the capacitors as they are in parallel. The current is given to us in the form of waveform. So my first work is to determine mathematically the waveform to equations, splitting it in 3 time zones from 0 to 1, 1 to 3 and 3 to 5 second. What are the corresponding equations? So first thing is this. Second, we will determine the C equivalent, because 6 microfarad and 4 microfarad are in parallel. So the net combination you will get 10 microfarad. Now the voltage equation we know 1 by C equivalent integral of the current with the initial voltage V of 0. So from 0 to 1 second, first we'll take from 0 to 1 second, what is the voltage? So we will find the voltage as 1.5 into T square kilovolt. So from 0 to 1 we are getting this voltage. Now from 1 to 3, if we put the value of the voltage V1 here, which is the voltage we are getting from the previous time. Now we are getting a new voltage from 1 to 3. So from 1 to 3 we are getting a voltage of 3T minus 1.5 kilovolt. Similarly, from 3 to 5 if we do it, then here we will be having the previous case and here we will substitute the current. So on integrating we will get the value of the voltage. Now we have got all the times and we can write down the equation of the voltage first for the division of the time 0 to 1 second, 1 to 3 second and 3 to 5 second, and then we can determine the current I1 and I2 because the current is C1 dV by dt, C2 dV by dt. Because both the capacitors are in parallel, the voltage will remain the same. So the current I1 which is flowing through the capacitor C1 will be equal to C dV by dt. The current I2 which is flowing through capacitor 2 will be equal to C2 dV by dt. So we will substitute the value of C1 and C2 and differentiate the voltage and then we'll get the current for different time instant. So I1 and I2 we have got it as a function of time t for different time instant. So this completes the tutorial on capacitors. Next tutorial will be on first order circuit.